We've introduced the imaginary number I, but the last remaining question is where actually is I? Where is it physically located? Okay, so we've looked before at the real number line. Okay, the real number line includes the natural numbers, the positive whole numbers, the integers, the whole numbers, positive and negative, the rational numbers, meaning fractions, and the irrational numbers, numbers which cannot be represented as fractions. All of these numbers are contained within the real number line. The question is, where do we put I, the imaginary number? Okay, well, we can think about it in these terms. I cannot be on this line, this one-dimensional real number line. It cannot be located on this line for the reason that no real number squared is equal to a negative number. Okay, that is not a property of the real numbers. Okay, so it cannot be on this line. So where is it? We can approach this question in the following way. Let's examine how I behaves under multiplication. Okay, let's start with the number 1 here. If we take number 1 and we multiply by I, okay, we get I. That's not so interesting. But imagine we do it twice. So we take 1 and we multiply by I twice. That's 1 times I squared, which is minus 1. So if you like, applying I twice to 1 brings us to minus 1. So we go from here back to here. Okay? So if you think about I as like an operator or something acting on I, it means 2 of them brings the number 1 to the number minus 1. Okay, if we try to imagine what this could possibly be, you're driven to the idea of the imaginary numbers being perpendicular to the real numbers. And the reason for that is, if you apply I twice, you get back to minus 1. So we can imagine multiplication by I as being a rotation of 90 degrees. If you rotate 90 degrees and then 90 degrees again, you get back to minus 1. Okay, but in order for this to be an accurate portrayal, it needs to be consistent. So one application of I, one multiplication by I, gets us to I. So that means that one 90-degree rotation would bring us to I. And that's why we have I on the perpendicular here. Okay? If we do if we start at the number 1 and we multiply by I cubed, that's the same thing as 1 times I squared, which is minus I. Okay, so another rotation should bring us down to minus I. And lastly, starting with the number 1, multiplying by I to the power 4, that's the same as 1 times I squared, which is equal to minus 1 times minus 1, which is equal to 1. So it is consistent. A fourth rotation will bring us back to where we started, to the number 1. Okay, so in some sense, multiplication by I can be interpreted as a 90-degree rotation. That's important. Now, if we extend the number system to this two-dimensional plane, where we have the real numbers along the x-axis, if you like, and the imaginary numbers along the y-axis, okay, this allows us to create the idea of a complex number. So a complex number is a combination of real and imaginary. Okay, so if you imagine this point here, this point in the complex plane, this point is some number along the real numbers combined with some number along the imaginary number line. Okay, so in general, we write that z is equal to a plus bi, where a is the real component and b is the imaginary component. And this combined object called a complex number. Good. This can also be written as it's equivalent to the ordered pair AB on the complex plane. Okay, you can just, this is just slightly different notation, it means the same thing. Okay, what I'm going to do now is look at the general case and multiply this complex number by I and see what it is that we get. Okay, so if I multiply I by Z, where Z now is any number in the complex plane, we get I times A plus BI, which is equal to A times I plus B times I squared, and that equals AI minus B, okay, which is equal to minus B plus AI if we rearrange so that the real comes first and the complex comes second. Well, that is equivalent to the ordered pair minus BA, and if you compare these two numbers, these two ordered pairs here, you'll see that if you look back at our previous transformations, a transformation which takes a point AB and moves it to a new point minus BA, that's the exact same as a rotation of 90 degrees. So multiplication by the imaginary number I is equivalent to a rotation of 90 degrees.